right, let's move on to the next problem where we have to use the mean value theorem. So again, if I had to give you the full intuition behind it, it would take a long time. So I'll just again give you the algorithm for solving these types of problems, and then I hope you have gotten the general understanding of the conceptual understanding in class, because in class you spend more time on this. Anyway, so here's the algorithm, and we just go through it step by step. So let me just copy the function that we're given, f of x equals x minus 4 over x. And then we care about the interval from -2 to -1, okay? So what is the first step of the mean value theorem? First step is to check whether our function is continuous over the interval that we're given. In other words, we need to check if our function is continuous over this interval. How do we check this? Well, we find a domain, and if this interval is within the domain, then it's continuous, okay? So the domain of f would be, well, so at first I have an x. X can take any value, doesn't matter. The more problematic part is this one, because I have an x in the denominator, which means that if x were 0, then it would be a problem because we cannot divide by 0, right? So this is actually a pretty regular function where the only invalid value is 0. So the domain of f is x, different from 0, right? It cannot be 0. Okay, and that's pretty much it. In order to write it more rigorously, we'll need to write it this way. F is continuous, C0 means continuous, over the interval from -infinity to 0, in union with 0 to +infinity. Basically, any value except for the 0. It cannot be 0, okay? And then, I've explained this in a previous video, it follows that f is also continuous over the interval from -2 to -1 by restriction. Right? Because if on the number line we know that 0 is the only invalid value, everything else is valid, then of course it's going to be valid between like -2 and -1. Of course it's defined, of course it's continuous, okay? All right, that's the logic. Next step, so that was the first step. Next step is to prove that f is differentiable on nearly the same interval, but this time it's going to be open. That's because we actually cannot really find the derivative at the endpoint specifically. But don't worry about it. Just remember that for the differentiability, it is going to be open interval. So how do we find the differentiability? We're going to perform the same exercise basically, but on the derivative. So we're not going to check the domain of f, but instead the domain of f prime. And of course, in order to find the domain of f prime, we're going to calculate f prime. So let's see, f prime of x will equal the derivative of x minus 4 over x, which we can just split to two different derivatives, right? That's x prime minus 4 over x prime. Derivative of x is just 1, right? Here, I would prefer to rewrite this as 4x to the minus first prime. Now, why minus first? Because I've told you that if you have this in the denominator, you can bring it to the numerator just with the opposite sign of the exponent. So that's what I just did. We know that whenever there's a constant in a derivative, we can just pull it before the derivative because it wouldn't change. So it's going to be 4 times derivative of x to the minus first. So that's 1 minus 4 times. And now for the derivative, first step is we bring this down. So it's going to be times minus 1. Then we copy the x. And the new exponent here would be the current one, minus 1. So we already have minus 1. And we subtract 1 more and we get minus 2, right? So minus 2. And then that's 1 plus 4x squared. Minus second power. And then I can simplify by writing this as 1 plus 4 over x squared. Okay? So when we're calculating, it's convenient to bring things to the numerator with the opposite sign, but once we have the final answer, it's slightly better to have them in this form, because now this shows us better what the domain of that derivative would be. So the domain of f prime would be x different from 0 again, right? Because 0 is the only problematic value. Okay. Therefore, I'm going to write it the following way. F is C1. Okay, so notice, when we're checking the domain of the original function, we write C0, which means continuous. When we're working with the domain of the derivative, we write C1. So f is differentiable on the interval from minus infinity to 0, union with 0 to plus infinity. That's actually the same as for continuity. So that's also fine. And therefore, f is also differentiable on the open interval -2 to -1. Where did that come from? It came from the problem itself, right? Okay, perfect. We're done with the first 2 steps. We have a few more to go. It's kind of exhausting, but now we have a formula. This is our formula. F prime of C. Oh, by the way, you actually need to write a full sentence on the exam. So you need to write it the following way. We prove that f is continuous over the interval. Oh, wait. We prove that f is continuous over the interval -2 to -1, and f is differentiable on the interval -2 to -1. Therefore, by the mean value theorem, it follows that there is a number c in, by the way, what's a, what's b? Whatever the numbers are. So here our numbers are -2, -1. That's a, that's b. So you're basically writing from whatever we calculated just now, it follows, where did that go? Oh my goodness. It follows that there is a number c in -2 to -1, such that f prime of c equals f of -2 minus f of -1 over -2 minus -1. Okay, so that's the idea, right? Instead of a and b, you just plug in whatever values are given in the problem, and you need to write the full statement. If you don't write a full statement, there's a chance that you will lose points. Okay, please just remember the sentence. Now, just for the purpose of saving time, I'm gonna directly write down the formula, right? So it follows that f prime of some point c is going to equal f of b, our b is -1, minus f of a, our a is -2, over b, which is -1, minus a, which is -2. And from here, we just calculate very carefully. Actually, let's just calculate these separately. Firstly, I need to find f of -1. Well, my original function f, actually, let me just copy the original function first. I'm sorry, it's just really hard when I don't have a full board to just show everything. The original f of x was x minus 4 over x. X minus 4 over x. That's the original function. And now the first time I'm going to plug -1 for x. F of -1 equals -1 minus 4 over -1, which is -1 plus 4, which gives me 3. F of -2 equals, now I just plug in -2 for x. So it's -2 minus 4 over -2, which is -2 plus 2, which gives me 0. Okay? So I found these values. Now we just need to continue with this formula. So f of -1, I just found that it's 3. F of -2, I just found it's 0. Over -1, minus and minus gives me a plus 2. So that's 3 over 1, which is 3. So what I just found is that f prime of some point c is equal to 3. And I need to find what that c is. Is it 1? Is it 10? Is it minus a million? I don't know. Okay. Now, how do I find this? Well, I already have the formula for f of x equals, f prime of x equals this thing. It equals 1 plus 4 over x squared. Therefore, if I use c instead, I'm going to have f prime of c equals 1 plus 4 over c squared. And now, guess what? I can substitute this expression in here. So I'm going to have 1 plus 4 over c squared equals 3. 4 over c squared, I'm just bringing this to the other side. It's going to be 3 minus 1, which is 2. 2 times c squared equals 4. C squared equals 2. Therefore, c is going to be plus minus square root of 2, right? Now, we're almost done. So this is what the question asked me about. It asked me for the c's, but you need to be very careful. I've written it down somewhere here. Whenever you find values for c, you need to check if they're within the interval you're working with. So in our case, the interval is minus 2 to minus 1. If I take positive square root of 2, this is not in the interval, so it doesn't count. If I take minus square root of 2, this is within the interval. It's exactly between minus 1 and minus 2. Therefore, this is the only valid c I would have. And of course, in the example, you just write a little bit more, right? So you write c equals square root of 2 does not belong to this interval. Therefore, it's not a valid value of c. Minus square root of 2 does belong to this interval. Therefore, it is a valid value of c. So your final answer to this question should be minus square root of 2.